In this video, we look at ways of representing sets and intervals on the real number line. Right up here in this example, we have what we call a closed interval, which means it includes the endpoints. So this interval here includes -2 and also includes -1. You can see that x can be equal to -2, x can be equal to -1. That's different from an open interval where x can't be 0 and x can't be 1 in this example. And you'll notice a difference in the circles. The circles, when x can't be equal to 1, the circle is empty. If x can be equal to -1 in this example, then we've got a full circle, a shaded circle here. So if you can include it, then the circle is shaded. If you can't, then it's open. If you have what we call an unbounded interval, for example, if x is just bigger than 5 and it can keep on going, it can be 6, 7, 1 million, 2 million, as big as you want, then we say it's an unbounded interval and we just have an arrow there to indicate that it goes on forever. Now, this is one way of writing an interval, with these inequality signs in here. Another way is to use these symbols. These square brackets mean that you can include the endpoints. So these ones here would be what you would use with this kind of interval. And you can see that the 0, 1 down here with the round brackets that we have, these round brackets mean that you don't include the endpoints. If you think about this one here, we don't include the 2, but we include the 4. So there's a round bracket at the 2 and a square bracket at the 4. And the way of writing this interval here, if x is bigger than 5, we can say, okay, starting at 5, but with a round bracket because we don't include 5, and going on to infinity. And infinity always has a round bracket. Infinity isn't really a number, it's just there to indicate that it keeps on going forever. Okay, so 5 infinity represents this interval here, going on forever. Now your next job is to try to fill in this table. There are missing pieces of this table right in here and in here. Anywhere there are gaps, you've got to try and fill it in with, first of all, the set description. And this set description here, incidentally, means that the set of all x such that, that's what that straight line means, a is less than or equal to x and x is less than or equal to b. So basically x is between a and b, and can include a and b. And this is the drawing of it over here. So the drawings, which should be down here, the set description should be down here, and the interval notation, sometimes you have to put that in, should be down here. Okay, so give yourselves maybe 5 to 10 minutes to try that now. Okay, we can check through those answers. I hope you've done them and you're not just continuing with this video. I hope you pressed pause on the video. There's no point in just watching me do it. So I hope you've tried these and you can just check now. So the first one, we can write like this. Remember, it's not including a and b. And I'll just give you the rest of the answers and you can check. On page 6, you should just check for yourself that you know how to use interval notation to represent these sets. So give yourselves just a minute to write in what you think should be the answers there. Pause the video, please. Okay, so the first one is from -5 up to 2, but doesn't include -5 and includes 2. So it's a round bracket at -5, representing the fact that it doesn't include -5, but a square bracket at 2, representing the fact that it can be equal to 2. And then the next one, x is less than 0. The easiest way to do that is like this. Now you might remember from doing sets in previous years, perhaps in other courses, there's something called the intersection of two sets. Basically, if you're in the intersection, you're in A and also you're in B. So if you think about these two sets, this one and this one, A and B, the only numbers that are in both sets, the only numbers that are in A and also in B are these ones. 4, 5, 6 is there, 4, 5, 6 is here. So the intersection A intersect B is 4, 5, 6. We can draw it on a Venn diagram like this. It's the things that are in A and also in B. Now that's different from the union of two sets. The union of two sets, if you're in the union of A and B, like this, it means you can be in A, or you can be in B, or you can be in both. So anything in this yellow piece here, and you might not have this shaded in your photocopies, and you perhaps could shade this yourself and shade this part yourself. This shaded part here is A union B. It's everything that's in A or B. Then we have something called the universal set. You can denote it with this special E letter or with U. That's a set of all possible members of a set, or all possible elements that you're interested in. So if you're thinking about letters of the alphabet, it could be A, B, C, D, E, F, G, all the way up to Z. Now the complement, which we denote with A and then a little dash, sometimes A with a little C, of set A, is a set of everything that's not in A. So if you look at this Venn diagram, you've got the universal set in this rectangle, you've got all the members of A in the orange piece, and then everything that's not inside this circle but inside the rectangle is the complement of A. And sometimes you're asked to try and put on a real number line, or try and find out the actual interval for the union of two sets, two intervals on your number line. So if you think about the intersect of this and this, basically it's all the numbers that are in this but also are in this. Now if we try to make a drawing of that, a drawing would start off looking something like this. Right? So you've got your -2, 3 here being this line, and you've got your 1 up to 5 being this line. Now where do you have to be in order to be in both? You've got to be right in here. You've got to be between the 1 and the 3. That's the only place where you can be in both sets. So on a number line, that's going to be between 1 and 3, right in here. In this next example, it's a union, so you can be in here or you can be in here. You can be anywhere between here or you can be anywhere there. So if you draw that on a number line, put both of them on a number line, it should look like this. So you can be anywhere in here, or you can be anywhere there. That means that you can be between -1 and 4, anywhere along that line. And the way of writing that, using special interval notation, would be like this, from -1 up to 4.